Thanks a lot. So then let's move to the final panel discussion. So we have a panel which will discuss how to optimize solar power plants, LCOE using bifacial and solar trackers, somewhat summarizing and reflecting the whole event. And we have with us Emmanuele Chiappori, Global Engineering Director, Antaisolar, who spoke already yesterday. Might have heard his presentation. Then we have Radovan Kopecek, a Managing Director and founding member of ISC Konstanz, who also spoke this morning. And then new to the event is Christos Monokroussos. He's a Global Segment Coordinator, Solar, TÜV Rheinland, and he's based in Shanghai. So I'm happy to have all of you. Let me just start. I just wanted to share my screen and start with one slide, because I think no one has shown that, but I found that actually pretty interesting. Next one, I think does that work? Yes, it does. Oops, it's the other way around now. Oops. Okay, I'll leave it also like this. So I just wanted to show this slide because I think it's very interesting. You can see here that's from a recent presentation from Bloomberg New Energy Finance, and you see that LCOEs somewhat go up because of the supply chain issues we are all facing these days, but nevertheless, solar is by far the lowest cost power generation technology among all technologies around the world, and the one which is leading is tracking PV. They don't say here if they use bifacial for that slide, but if not, the LCOE would be even better. So I just wanted to use that as a start, and now back to the panel. Wait one second. Maybe Rado, for you, 1 second. First, I have to find my. Okay. So. Maybe let's start with you once again, Rado. I think there was also an issue this morning due to a miscommunication. A few people dialed in a half hour later because actually we started half hour earlier than yesterday. So maybe you can look once again from a researcher's point of view about bifacial modules, which we really know for decades, but only started its uplift a few years ago. Why is that actually that finally bifacial is getting traction? And I think in power plants it has become a standard now.
Okay, Michael, thanks for the question. And yes, this is actually a natural evolution of crystalline silicon photovoltaics. I mean, we started to organize bifacial workshops already 10 years ago in 2012. But as you know, at that time, it was dominated by aluminum back surface field, and it was quite, conservative industry. And in 2016, when LONGi brought cost-effective monocrystalline wafers on the market, actually the innovation started. And then quite soon, bifacial PERC was in the market, and so on. So it was because of the conservative market, but we were quite sure that bifaciality will come, because that's a natural evolution. If you want to have every year an improved efficiency, somehow you have to shift technologies. You have to go from aluminum back surface field to PERC, and this can be made bifacial then. And now you have to go to N-type technologies, and these technologies are even more bifacial. So that's a natural evolution. We wanted to make this quicker, that bifaciality will come on market quicker, but that was also a question of bankability, and there were no simulations program out there. If we would have such a great simulation tool from PVKs, then let's say the investors would go much faster there. But we were discussing with PVSys, please implement the bifacial function into your system because investors need bankable simulation programs. But PVSys was answering us for many years, there is no bifacial market. So it was more or less like chicken and egg at that time. And now bifaciality is bankable. Everybody knows that it makes sense, but it took a long time. So it's a matter of technology, natural evolution, and making the technology bankable.
Okay, so so that means if you just quickly reflect on the milestones, you said of course LONGi making or bringing PERC to the market. So that means we're basically at the beginning now. We see it already standardized. You also showed some other applications in your presentation this morning. So I think I found it really interesting that you can use it even for balcony solar, which actually everyone should have, especially in Europe, where we are facing a major gas crisis. So can you just say or mention the highlights once again from your side of view?
Yes. So actually, as I said before, LONGi started with monocrystalline to make this cheap, and then this came with the PERC technology on the market. So bifaciality started with N-type, but that was obviously too costly. A big breakthrough was then when bifacial PERC came on the market. A second very important thing was also when the white reflectors between the cells were implemented into the modules, because at that time, then after that, you were not cannibalizing the front side power anymore. And then the bifacial producers could sell the bifacial modules at the same power. This was extremely important for a big breakthrough. And now you named it. I mean, there are many niche markets for bifaciality, but I believe that also the innovations that are now like N-type technologies on balconies, on vertical roof, vertical installations where bifaciality plays very much role. Now N-type is penetrating also into the utility scale, but starting from niche markets, as you said, and then are also visible in the MENA states. Like Jinko was showing 200 megawatt. Jollywood is having now huge installations in the MENA states, basically because of high temperatures and high albedo out there. And there N-type is an advantage, but let's say when it will become with the cost now even closer to the PERC technology, then it will be everywhere. So, and this is the natural way how innovations are implemented into the PV market, that you go through niche applications like rooftops, balcony applications, to utility scale systems where bifaciality is now, for example, very important, as these vertical agricultural PV systems, and then it will enter the huge utility scale. Okay.
Christos, so when did you first start testing larger volumes of bifacial modules, and what were the initial issues you saw?
Thank you, Faivel, for the invitation, first of all. So we saw that the turn into bifacial modules started in late 2016 with 2017, where many manufacturers started mass production of bifacial module types. Since then, of course, bifacial modules have further increased their market share. Talking about the issues, right, which early we had with bifacial module, in the beginning, it was generally the lack of standardization for IV characterization of PV modules. So people were asking how to take into account the rear phase contribution of bifacial modules. Since then, IC 60904-1-2, together with the second edition of 61215, have been published, And it's quite clear now how to account for the rear side contribution of bifacial modules, at least when we do the power rating. We also had issues related to the reliability of first bifacial types. So in the very beginning, I remember bifacial modules came with nearly gigantic junction boxes, which were positioned right in the middle. And they also had larger sails, so both of them would introduce significant shading. And of course, this would result into lower energy yield. Lower energy yield, but also increased thermal stress, hotspot, due to the current imbalance that is generated from the rear side. Since then, we have seen several improvements. So now, these days, bifacial modules comes with 3 small junction boxes, which are positioned smartly to minimize shading. And also the labels are significantly smaller in size. And they also help to avoid shading and current imbalance. Early designs, we have also seen delamination and discolorations around the edges of PV module that was evident after sequence B of 67030, which implied that there were issues with the adhesion of the EVA, but also with the edge sealants. So these days, we no longer see such failures, which means that the industry has learned its lessons and they have improved the lamination process. Another issue was the mechanical robustness of bifacial module designs. So initially, manufacturers were concerned about cost, so they tried to remove frames from bifacial modules, or minimize them at least, which resulted in several mechanical load failures. After that, manufacturers increased the glass thickness to compensate for mechanical endurance of bifacial modules when frame has been removed. So these days, bifacial modules are very large, so no one is talking about completely removing the frames anymore. So I think more or less this is also tackled. Another issue for bifacial modules that we have seen in the beginning was bypass diodes. So early module types came with bypass diodes that were rated as high as 15 ampere, which was not suitable to cope with the increased currents that bifacial module will have in the field. So today, manufacturers have increased the rating of bypass diodes to 20 ampere or 25 ampere or even 30 ampere, they can endure significantly higher currents. And the last thing which I would like to mention is that we also had in the early days, we had also issues with the reliability of the rated power of bifacial modules, considering also the rear side contribution of them. So people were inexperienced on how to perform this test. So we have seen deviation as high as 5% to the actual power that we measured in the lab. So these days, I think there is better experience and this problem is under much better control. So the deviations that we see in the lab have also decreased.
Okay. You said, I remember also that then when the standard was missing, we've also now an updated 61215 standard. So can you just elaborate a little bit more how the new standards helped and what actually they define?
Right. So the second edition of 61215 was largely based on a TÜV Rheinland internal standard, the 2PFG 2665. Which addressed all reliability issues that the bifacial modules will have in the field. So firstly, bifacial modules may see larger currents in the field comparing to they will operate, they will see higher IMPP comparing to the STC IMPP because of the rear contribution. And this additional contribution on average varies between 7 to 15%. So in several cases, larger currents, up to 30% can be seen. For example, when you have sunshine and which followed by a snowfall. So when the ground is reflected, very highly reflective, then a bifacial module may have up to 30% additional contribution. So the new edition of 61215, the operating current in reliability test has significantly increased by approximately 30%. So this results in additional thermal stress, which may become an issue when hotspot is testing or thermal cycling is done, or when the bypass diodes are tested. Secondly, the EU standard has a gate requirement not only for the power of bifacial modules, but also for the power verification at bifacial nameplate irradiance, or BNPI as we call it. The latter is the irradiance which the nameplate verification is performed for bifacial modules, corresponding to 1000 watts per square meter front irradiance and 135 watts per square meter rear irradiance. Furthermore, the changes of the BNPI performance are also accounted for when assessing the degradation of bifacial modules for the reliability tests. So overall, I would say the second edition of 6.12.15 has the ability to differentiate between good and bad bifacial module designs and ensure the reliable and safe operation in the field.
Okay, and maybe you can also give a little bit of background what you experienced while using the standard also recently.
So yes, so like I have mentioned, the standard has been more or less based on the 2PFZ 2665. So the experience which we already had carries on. So like I mentioned before, in the beginning, we had issues with hotspot tests. We have seen a lot of failures. Also, we have significant failures occurring for bypass diodes we're testing. But generally, we see a lot less failures these days. Okay, okay. There's also another standard. If we're just talking about standards, we can wrap that up maybe. 6.17.30 will be also, so regarding safety, that will be also soon updated and then include bifacial, if I understand. So can you also summarize that and explain what to expect? Right. So first of all, the module safety tests which relate to bifacial module reliability are more or less identical between the IC 6.12.15, which focuses more on quality and performance, and the IC 6.70.30. So for module types that have already qualified to the second edition of 6.12.15, not much will change because these tests have been are carried out anyway. However, for module types that have not been qualified to 6.12.15, it will become harder to qualify because modules would have to prove their endurance under much higher operating currents. So this is, of course, as far as bifacial performance, quality, and safety are concerned. Okay, okay. Then let's move to trackers and also look a little bit back. So I think if you look at today's trackers, it's amazing how much technology and intelligence is in there. So Emmanuele, if I understood well, and when I looked at your LinkedIn profile, you have been actually not only in solar and in wind, but you have been in CPV also already earlier in your career. So when you look at at trackers who are then commercially being used and also in PV actually for quite a while and much longer than bifacial. So how do you see the evolution and what are the highlights you basically observed over the last 2 decades?
Okay, so can you hear me well?
Yeah.
Okay, so there have been many changes in the last 20 years. So we went from very small utility plant of, I don't know, 50 kilowatt was a big one 15 years ago. Now we're talking about 300 megawatt. So the sites, all the logistic around the industry is completely different. The production, the quality management, everything around the industry is going towards like an automotive industry. So you need to really build up a series of many figures around all this project. Okay, so this is just a general consideration about the industry. So it's a completely different industry. So what I can see now is that there are thousands of projects around the world, many projects, and there are also a lot of uncertainties because so the main roles in this sort of project are developers, engineer, procurement, constructor, and below them all the the providers of tracker, just like Antaisolar, inverters, and all the work that are needed around this sort of project by, for example, civil works and other. So the way all this chain is organized is not always clear, because the role of every ring of this chain are not clearly defined. So this project do not get the efficiency they deserve. Okay, in terms of organization, I'm talking about. Okay, so sometimes there are many uncertainties under the point of view of the let's say the financial aspect of the project, because developers don't know exactly how much money they can get thanks to this project. So we're not longer talking of small plants like 20 years ago, but we are talking about big plants. So everything around is big. So a small mistake is just kind of multiplied by a big number. So the need of understanding in detail all the aspect of this project. I'm just not talking about the tracker aspect of the project, but all the project it's very important. So for example, like software like the one presented before, PVKs, can help a lot to get a good estimate of the overall project. Okay, so these are general consideration around the project. So they have to switch to small to big project. There is a lot of uncertainty on the benefit of it. So there is the need to define as much as possible all the aspect around the project. Okay. And talking as under the tracker point of view, what I have to say is that there has been in the last few years a strong tendencies to reduce cost. So I think that this is something that had been pointed out in previous presentation. So there is this strong tendency to try to reduce cost, and provider like trackers are almost at the bottom of this chain of project. So we do normally suffer from this approach. Okay, so my thought regarding this fact is that probably it would be better to kind of increase the safety of this project in order to get a good performance along the 25-30 years of the project itself. Okay, so there are some cost reduction that have been applied in many projects, which under my humble point of view are not so necessary, because projects, this sort of project, you can see that all the cost of the panels, the efficiency, the bifacial efficiency, everything is getting better. So there is margin for profit in this project. So the best things to do is try to build up a solid project under the point of view of all the components. So I think this is kind of a tendency that has to be changed into the photovoltaic sector.
But if we look back, actually, I think we actually, when we look into history, we always know what's coming, right? So I think PERC was invented by Martin Green, I don't know, in the 1990s or something like this. I recall also having 2-axis trackers early 2000 from Solon. They even had modules that were at that time 1 kilowatt. I think Q cells already had 8-inch cells also a long time ago. So we actually all know what's coming more or less. Even if then there's maybe sometimes it goes too quick, then there's a little break because of course the 2-axis trackers only worked because of the very generous Spanish feed-in tariffs at that time. And then they disappeared. But in the end, actually, we know what's coming, right? So to everyone, so
yes. I think we know. I mean, the industry is getting the expertise of the industry are increasing a lot. So there are a lot of software of professional which have been working in the industry for many years. So we know which direction we have to avoid. There are new challenges. For example, yesterday was pointed out. The fact that now all these utility scale plants probably will have to be installed into much more abrupt terrains, so which higher slopes, and all these affects to a lot of aspects of the project, wind loads, backtracking, bifacial gain. So there is a very good understanding curve. But also new challenges to be faced in the future. But the industry is, as Michael said, is definitely going to known terrain. So we know what we can expect in the near future. Still being challenging.
And if we talk about reliability, I think we are building power plants that should last a while. And we are also seeing, I think that was interesting with bifacial modules, because that really brought actually a jump in terms of performance warranties. So I think then we had glass modules, and to simply show, I believe, in the beginning that this is really reliable. The first manufacturers started to offer 30-year warranties. Then we had the transparent back sheets, and they actually said, oh yeah, we are as good as you, so we also have 30-year warranties. And is this all justifiable? So I think theoretically a solar module could last 40 years, and as we saw with new cell technologies, there's fewer degradation and so on. So, but can we look at this and discuss it a little bit? This whole long-lasting production possibilities of solar. Maybe Rado, start.
Yes, you said a good sentence. Michael, we know what's coming, and I'm always very surprised that people are then surprised that bifaciality is coming, because I mean it's a natural evolution, and now we are also saying that bifacial IBC will be, let's say, the next big thing after TOPCon, because I mean if you want to increase the efficiency, you naturally have to go to IBC, and ICO and Longi are going that way, because IBC, there's a huge fear of IBC out there, because it's complicated, it's complex, the module technology is complicated. It's not. And now coming to your questions, yes, it's justifiable, because in 1990s people were installing glass modules at that time with silicone encapsulants, and they are still working at 80% performance. So glass is of course better solution, but let's say that's not coming with bifaciality. You can also put, of course, monofacial solar cells in there. What is necessary with bifacial cells, because you have both open sides, the front side and rear side, so you have two kinds of potential induced degradation. And that's the new thing, that you have the shunts and the polarization. That's why you need a very good encapsulant in order not to have PID in bifacial modules. So if you go glass-glass, you need also not only with N-type, but also with bifacial P-type to go to polyolefins. So more or less the bifacial module are a little bit more costly because of the good ingredients that you are putting inside, but the long-time stability is justified. You can really go to 30 or even 40 years. And this is, let's say, a new trend that we are not trying to make the module cheaper, putting low-cost EVA and lower-cost back sheets, but really to increase the power by bifaciality, by increasing the front side and putting better BOM inside, like better materials. And this goes also hand in hand with the higher guarantees and lower degradations.
Okay, but does it actually work? I think Genia made a good point also yesterday from PVL. He said, found that interesting. I never thought about that, but he said, okay, now that we have also this localization taking place, we will have new manufacturers and we have people actually coming into manufacturing that are not really trained in this. So I think the Chinese have built now quite some expertise. I think we in Europe lost some of that, the Americans even more. And he said actually that might have also impacts on quality. I don't know, Christos, are you seeing that actually also when new manufacturers, I think Genia was also pointing when the Chinese started to get big, that had also brought quality issues. Are you seeing that when you see new module manufacturers coming, that we're seeing
coming from Europe or
anywhere?
No, we see that there is a consolidation of manufacturers. So in the beginning, we had a lot of players and they're becoming less and less. So I don't see new manufacturers coming. Of course, now with the crisis in Europe, there is a big debate of whether it will encourage local production also in other, to move away from Southeast Asia. These are the only discussions. It is yet to be proven, you know. So I cannot comment on this, but I can only say that right now I don't see new players coming into this.
But in India, we have a couple of them, right? And I think at some point there was also in Vietnam new companies coming online. So I think so. So my question is rather, whenever you saw new manufacturers and you saw their products, actually, did you see in quality testing issues that you didn't see with established companies anymore?
No, it depends. It depends from case to case. There are definitely cases that we have seen that they don't have, they lack expertise, but we have also seen cases where we have tested new products and it was able to pass all tests without any failures. So I don't think we should generalize here. It depends from case to case.
Okay. And regarding actually maybe also when we think about cost, of course, we've seen so much improvements also. I think it's maybe debatable from a point of sustainability, but I think with all these dramatic improvements, repowering can actually make sense in power plants from a cost point of view, even much earlier than waiting 30 years or more until the lifetime of the module comes to an end. So what are we seeing here?
Right, when it goes to cost. So first of all, I would say energy yield prediction is very important to prove that bifacial applications would have the return of investment for new installations. So bifacial modules, the energy yield of bifacial modules we have seen like PVKs, but I would say that generally it is still an object of current research. PVCs, for example, still have work to do. In most cases, the rear phase irradiance and the underlying bifacial contribution is crudely approximated by tools. So we see that bifacial modules, in order to achieve maturity, that the tools also that we have been using for EYP also need to mature. Furthermore, I think also PAN files would help reduce cost for bifacial modules. So we see that PAN files, they need to accurately portray bifacial module performance. But there is a significant amount of PAN files that are forged in the market, or they have manipulated data. So here, I strongly believe that third-party verified PAN files would be also important and would also promote bifacial technologies in the market. So talking about cost in general, well, you know, in order to further reduce cost, you need to invest in innovation, and both bifacial modules and trackers are product of innovation. Yeah, we should not stop innovation efforts. But last and not least, I would say that innovation itself is not enough. You also have to have coupled with policies which would promote the use of renewable energies and green energies in general.
Okay, and then, but talking once again about bifacial quality once again. So talking a little on modules and all this, this big modules in the large form factor of 600 watt plus modules, we saw 700 watt modules now coming to the market. As I said, I think there was already a 1 kilowatt module at a time. So how are you seeing that in terms of reliability, also regarding mechanical failures, thermomechanical failures, Christos?
So new module types that can deliver above 600 watts or close to 700 watts, as you mentioned, are larger, right, by definition. And hence they are prone to failure modes related to the mechanical integrity. So we recommend that endurance to static and dynamic mechanical load is tested. Another issue with large modules is not the mechanical integrity. It's related to the solar simulators. So non-uniformity of irradiance of solar simulators has to meet certain requirements. So if you want to have a good accurate rating of PV module, you need to have at least, let's say, class A requirement or A+. Generally, the larger the area, the more challenging is to achieve low non-uniformity of irradiance and ensure rated power. So using solar simulators which can achieve low non-uniformity of irradiance over a larger area is important. And there are such simulators in the market, but they are more expensive. So overall, mechanical integrity and also non-uniformity of irradiance is a challenge for larger module sizes.
Okay, maybe Rado, when you look at the bifacial modules you've seen in the field, actually, I think you already seen many. So what were the problems you saw there actually with the early ones, and I think how that, and what you're still seeing actually also these days when we have, of course, also this the supply chain issues, cost problems.
Yes, so when it was a new product, the bifacial module, then of course, as Christos already said, I mean, there were also problems with the junction boxes too large, and now it's adapted. We have very shallow junction boxes and so on. And in PERC technology, the problems were also that it was not clear from the beginning that there will be another potential induced degradation in the modules, which has to be prevented, because PID was a big issue 7 years ago. and then it was solved for the front side. And then when bifaciality came into the market, then it became an issue also for the rear side. So then people had to adjust the materials and so on. And regarding also to your last question, Michael, so I think for PERC, nearly everything is understood, and there are still some strange effects also with the gallium doped PERC modules, that they still have some degradation if there's some metal included in there, like gallium iron complexes and so on. So let's say gallium p-type doped wafers are also not perfect when you do not have the knowledge about it. I'm a little bit worrying more about the TOPCon technology, because there's very few producers at the moment, which is Jollywood and Jinko, and they know what they are doing. But there will be, as you mentioned, many new smaller producers that will come up with TOPCon, and there are some issues that you have to consider in order to make a stable TOPCon cell. It comes also with UV degradation, so I'm sure that we will see new effects in TOPCon bifacial modules out there, not from the tier 1 manufacturers, but from small manufacturers that will have, I mean, N-type can also have LITID when you do not, for example, process the solar cells perfectly. So N-type can also have some degradations, degradation modes, which the small manufacturers will have, I'm sure. So if then we will enter, as I call it, the NPV era, I'm sure we will see also some additional effects which do not see at the moment.
Mm-hmm. And how is it with trackers, Emmanuele? So I think you talked about wind load modeling. So of course now we see I think specific and singular tracking for rolling terrains. So and I think the companies reacted quickly to deal also with the higher currents of the large modules. So it feels to me, I think the learning curve on the tracker side was actually very steep. So I think to adapt also what was coming in terms of innovation from the module side. So what would you see actually the biggest reliability changes today actually in a world with these more powerful, bigger modules, and also at a time when we of course have cost issues due to the supply chain constraints?
Yes, Michael. There are many challenges. I just wanted to point out a couple of things before answering your question, because we have been talking a lot about bifacial performances, and we have developed a study with the IES, is Solar Institute here in Madrid, and we have analyzing more details. It's a work still in progress, but we have analyzed it in more detail the actual bifacial gain, okay, under the electrical point of view. So we have seen, as also many tracker companies pointed out, that it's this gain is strongly dependent on the structure around build up around the module, of course. So for example, in software-like PV case, I think it's very interesting that they have a 3D, as was said, a 3D model to foresee the bifacial gainers, but there are, I probably don't think that there are sufficient details of the tracker itself, because small differences in the tracker geometry have a big influence on the actual gain of the back panel irradiance and also electricity production. So I think that there is a margin for an R&D job there to improve these models that foresee this bifacial gain, because for example, in a two portrait tracker solution, the effect of the purlins is not often taken into consideration, because they even if there is a gap, an important gap in two portrait solution with respect to 1P solution tracker, the long purlins that are supporting these solar panels generate sort of shadows, okay, because I mean there is an incidence angle of the sun, so everything below the panel has an influence. It is not always too clear how much it influences, so there is an important job to do there. Okay, so this is kind of parenthesis to link to the previous conversation. And regarding your question, Michael, of course, higher panel are represent a higher challenge for us under the tracker structural point of view. There are some weird situations because sometimes you have shorter trackers. So as I said before, developers are often confused about the better configuration of the tracker versus their layout. So sometimes we have to switch from 3 strings in a tracker to 2 strings, because 3 strings with bigger module would have been too long for certain tracker solutions, and 2 strings are, even if the solar panels are bigger, in the end are shorter. Okay, so we may add sometimes shorter trackers to match some requirement of some developers. Okay, so and also certain terrain force to implement solution with the shorter trackers sometimes. Okay, so in reality, the fact that there are bigger panels is kind of changing the input for us. It is also true that in general we may need solution with very long trackers. So as I said yesterday in the presentation, the best way to do that, as Antai is doing, is to provide the trackers with the multi-point solution and to have as many block points along the torque tube as possible. Obviously, cost dependent, okay, because you cannot just put under every pile here a fixed point, because it's going to be very expensive, the tracker. So it is a challenge. Also the short of the panel, so the length, so the short under the wind load, because it's increasing. So not just the length of the tracker is increasing, but the short of the tracker, it can goes up to 5 meters sometimes. So wind tunnel study normally has a gap of validity of their studies, so they give you some margins. So they perform tests over a model, for example, 4 meters, and they say the coefficient, the instability, the dynamic amplification factor are valid from 3 to 5 meters, for example, just to put an example. So sometimes with these new panels, we are at the limit of these studies. Okay, so we are at the upper limit of the studies. So we need to pay attention that the wind tunnel results are still valid for this panel. And I also think that there is a strong need to verify the integrity of the panel itself. It was pointed out before, because they are bigger, but they still have 4 fixing points. So there is, I mean, everything below the panel has to be strong enough, but the panel as well need to be strong enough to be compatible with an underneath structure.
Okay, so let's briefly, so we're coming close to the end, so I think, so very briefly once again on cost. So if we look at where we are today, so everyone maybe 3 points in how can we further decrease costs in terms of on the module side actually and the tracker side. So if you have something to add to decrease the LCOE, maybe Rado first.
Yes, so on the panel side, of course, going towards higher front side efficiency, higher bifaciality, and coming closer with the cost to PERC. And of course, we know we have to reduce the silver consumption in N-type, and there are many companies and institutes working on replacing silver by copper. So there is still reduction potential of the panels, but I think that the higher potential is even on the balance of system side, and also if you have high bifaciality in your modules, then it also makes sense to start with conditioning the ground and really get a lot also from the rear side. This is what we saw from the IBRI project from where Jollywood supplied the modules, and they are now also making the ground white with some reflectors and so on. So let's say for PERC modules, this is at the moment not very cost effective because the conditioning costs more than the benefit is. But if you have really high bifacial modules, then it can pay off. And also one thing is we should not transport trackers and panels thousands of kilometers. So I think there are also other costs that we can save.
Christos?
Yes, so I answered this question to you before, right? I was talking about cost. So just to summarize, EOIP, energy yield prediction, technology innovation, and policies.
Okay, Emmanuele?
So there are many points to observe to reduce costs. So we need a better understanding of the layout of the solar plants, better understanding of the terrain, the orography, in order to predict better the wind loads, better understanding of the backtracking, in order to increase the yield, better understanding of the bifacial radiance to better capture it. It's an industry which is going to give us a lot of interesting work and jobs in the future, and fortunately there are these points to work on to increase the efficiency of the overall system. Because what is very important to consider is that all these solar plants need to be seen as an whole product. So it's very important to link all the components between the other.
Okay, so maybe one final question to everyone. So in 5 years from now, so you just basically conclude the sentence. So in 5 years from now, basically every large-scale ground-mounted solar systems, and I'm talking also about the somewhat more northern ones, not only will use bifacial N-type modules, but also trackers, because maybe Rado first again.
So you said already that it will be like that, and I have to say because
you can say also it won't.
It won't. Yes, so I think 5 years from now still there will be a mix of PERC and TOPCon heterojunction trackers, still fixed tilt, because that does not, let's say, only depend on bringing the most out of a system, but also do you have like experts on site that can handle the mechanical problems and things like that. So I was, let's say, for a long time not a very good friend for trackers, because for me PV was like great because nothing is moving. I'm now a very big fan of trackers because it increases the yield also of bifacial panels, and the simple trackers are just amazing. However, I believe that fixed tilt will be still out there also in big ground mounted systems. And yes, so it will be a mix, but the majority, I'm quite sure it will be tracking N-type systems in future.
Okay, Christos?
Yeah, yes and no. So of course, the market shares of bifacial modules in tracker would increase. But if you want to say that 100% of the modules would be bifacial module with trackers, probably no. So expecting to see a market share increase for sure. Have I answered your question?
Okay. Vidal? Emmanuele, sorry.
Yeah, so it will obviously increase the market of bifacial and tracker and everything. But I also think there will be changes under the point of view of, for example, combining storage system with solar plants. So this will lead to probably different sides of solar plant. There will be many pilot plants just to verify some good matching between some sort of system with the solar plants. Also, there is a strong need of changing all the electrical distribution in many countries because there are, for example, in Spain, everything is very centralized. Okay, so there is a tendency, as Christos said, it also depends a lot on politics, but there is a tendency to go toward distributed energy supply. So this will lead to certain solar plant, probably not too big, and so these will slightly change or create a branch of this industry from here to 5 years. Okay, so there are other aspects around, not just bifacial tracker or fixed structure. There are other changes, other aspects, other technologies around the industry, which will influence the solar industry. I don't know if I answered the question, Michael.
Okay. I think there's still a few questions on the chat, but I think we're running out of time. We will try to address them also in our upcoming market survey on trackers, which will be published in August. So once again, thanks a lot to you, my panelists, for this great panel. Thanks to all the speakers. Thanks to the attendees. Thanks to the Taiyang team. Thanks, of course, to our sponsors. I wish you a nice
and thanks to you, Michael.
Or evening. Thanks.
Thank you so much.
Talk to you soon. All the best. Huh?
Bye.
Bye. Thanks.
Bye.